the new chapter, chapter number 3, that is understanding quadrilaterals. Before we go for the quadrilaterals, let us understand what are the polygons. We are very much aware with the terms, but let us recall what are the polygons. The polygons are the simplest closed curves made up of only with the line segment. Let us understand the meanings. Polygon are the simplest closed curves which are made up of the line segments only. So now I will draw few of the diagram. So let us understand out of this which are the polygons and which are not. So let's see that which are the which are the line segments. So we observe in all the diagrams, they all are the line segments. Second, the closed figure. So we can say this one closed, closed, closed. It is not closed. But remember, these two are also considered as not simple closed curve or simple closed line segment or figure. These two are not simple and it is not closed. So we can say that these are not polygons, where these are the polygons, because it is closed and they are made up of the line segments. We can draw many of this. If I draw a circle, so remember that circle is made up of n number of line segments, which is quite complicated to understand you. But right now we'll discuss with that only the line segments with the closed figure and with the simple diagram. So we can say these are the polygons. Let's see the classification of polygons, which based on the vertex or we can say the sides. So the number of sides are there, or we can see the vertex also, the name of the triangle, fine, or we can say how it would look like. So it's figure. So if I take only one side or one line segment, we can say that won't form a polygon. If I take two sides, so again that won't form a polygon. So we can say that 3 is the smallest number of sides which we require to form a polygon. 3 sides when it forms, so we can give the name that polygon as a triangle. We all know the triangle with the 3 sides. So we can consider triangle is the smallest polygon. Remember this, it is the smallest. This could be the MCQ in the exam. Now with the 4 sides, so the name is given quadrilateral. That is the name of the chapter. Fine. So quadrilateral, different types. Or we can say rectangle, square. This blackboard, it's a rectangle. If 5 sides, so it is pentagon. We know pentagon, so it with the 5 sides, like the heart we used to draw in the drawing. 6, hexagon. So it must have the 6 sides. Let me just rechange it. 6 sides which we have to draw. So like this, 7 it is heptagon, 8 it is octagon, and 9 it is nonagon, and if it is 10 it is called decagon, and if it is n number of sides it is called n-gon. Fine. So this is the name, or we can say the classification of the polygon based on the number of sides and number of vertices. Let us understand what are the diagonals of a polygon. So let's understand the definitions, then we'll find out the diagonals of this. The diagonal is a line segment. It's other than the line segment of this polygon. It is a line segment which is connecting two non-consecutive. Non-consecutive matlab this A and B are consecutive, A and D are consecutive, D and C are consecutive. Non-consecutive, तो हम बोल सकते हैं A and C are non-consecutive as well as B and D. Non-consecutive मतलब साथ में ना हो. So which are the non-consecutive vertex of L? So L के non-consecutive vertex are N, O, P. M and Q are considered as the consecutive. Consecutive मतलब साथ वाले. Fine. Okay. So the definition says that a diagonal is a line segment connecting two non-consecutive vertices of a polygon. मतलब जो non-consecutive है और vertex उसको join करना है. If I try to draw here, we can see the consecutive sides of P is vertex of P is Q and R. तो यहाँ पे तो डायगोनल बनेगा ही नहीं. So we can say that diagonal of this or smallest polygon does not exist. Let's see for this. It's a quadrilateral. So we can join AC is one diagonal and BD is another diagonal. So we form two diagonals here. Here we form 0. That means no diagonal. So let's go for the 6 sides. There are 6 sides. It's a hexagon. 1, 2, 3, 4, 5, 6. There are 6 sides. So except the non-consecutive, L, M or Q के अलावा L should be joined with M and P. Let's go with the M. N should not be joined with L and N. So it should be joined with Q, P and O. The same way, N should not join with M and O. It is already joined with L. So one more. Okay. Now with O, which we have already joined to, one is left. Now with here, so it is already joined. So this many line segments are there. So let's find out how many are there. So when we count it at the time when we draw it, so we'll obtain there are 9 line segments. So one is LN, LO, LP 3, then MQ 4, MP 5, 6, then 7, 8, and the last one we joined this one. So it is the 9th one. So suppose they are asked that how many line segments or how many diagonals a heptagon or nonagon or decagon has, which has 10 sides. So this is quite difficult. So we have one formula to find out the number of diagonals a polygon has. So students, please note it down later on. You pause the video and note it down the formula. The number of diagonals of a polygon. So the formula is n minus 3 upon 2. So let us understand what is n. So we can consider n as number of sides of polygon. Now when you start substituting the value of here, this for triangle, let's see. Let's try to find it out. I'll do it. How many sides a triangle has? 3. So for this we can write n as 3. When I substitute here, so we'll get 3. 3 minus 3 upon 2. So you can see 3 minus 3 is 0, so we obtain 0. Let me do the same for this. How many sides it has? N is the number of sides we can say, or vertex. So let me substitute 4. I am substituting n4 in this formula. 4 minus 3 upon 2. 2 2s are 4. So 2 into 1. So we obtain 2. I hope you are getting. The same way, let us substitute this value here. N is equals to, it's a 6 sides. It's a hexagon. So when I'll substitute n is 6, I'll do it here. Then I'll rub it. 6 minus 3 upon 2. So it is 2 5s are. And 5, oh sorry, 6, 2 3s are, and 3 into 3, so it is 9. Thus it obtains 9. So you can remember this formula. Let me just erase it. So this is the formula which is very important. So please note it down. Thank you. Let's see that what is concave or which are the convex polygons. So how do we identify whether the given polynomials are concave or convex? So that is one absolute clear concept. Look at all the angles here, A, B, C, D at vertex. You can see that we feel it is 90. Okay, great. Look at this, all the angles here. All the angles we can find they are obtuse angle greater than 90. But now look at into this figure. So look at this angle R. Look at this angle N. So you can see that the measure of angle R and measure of angle N is greater than 180. So you can see that these two polygons are considered as a concave polygons. So what the definition is? The definition of a concave polygon is if one of the angle of a polygon is greater than 180. I repeat, if one of the angle of a polygon is greater than 180, then they are considered as a concave polygon. And if all the angles Or we can say none of the angle is greater than 180. So we can consider that it's a convex polygon. You observe one more thing, when we construct the diagrams, they intersect here. When we construct the diagonals, you can see that the diagonals, they intersect with each other. There are many diagonals it has, but you can see they are intersecting with each other. But look at this, if I draw the diagonals PR and QS, so look at this, they are not intersecting. So this can be the another way we can say that even when the diagonals are not intersecting with each other, are considered as a concave polygon. Let's understand what are regular and irregular polygons. So it's a very simple concept. The regular polygons, the polygons which have all the sides as well as all the angles are equal. That means they are equilateral as well as equiangular. मतलब all sides equal होने चाहिए, all angles be equal. Both the conditions are essential, necessary. All sides and all angles must be equal. So you can see that it's a triangle. It is an equilateral triangle. So I have done one line segment like this. It shows that the sides are equal as well as for this angle. So it is if we can consider it's a regular polygon. Let's see, this is also a triangle. You can see that PQ and QR, these are the two sides are equal by using this symbol. But PR is the different, which we used to call the hypotenuse. As it is a right angle triangle, so one angle is 90, the rest can be equal. So here these two angles are equal, but third is not equal. So this won't be an regular polygon. So it is an irregular polygon. The same way look at this square. So in square we have all four sides as well as four angles are same. All sides and all angles are same. So we can consider it is a regular polygon. The same way you can see the rectangle, as all angles are same 90, but look at this, only the pair of opposite sides are equal. सारे sides equal नहीं है, सिर्फ आमने सामने वाले दो sides equal है. So this consider as an irregular polygon. Let us discuss that angle-sum property of a quadrilateral. We are absolutely aware with the angle-sum property of a triangle. That means sum of all the angles of a triangle is 180. So you can see that it's a quadrilateral. It has four angles, angle 1, 2, 3 and 4. So the sum of all angles of a quadrilateral is 360. Let's see how it is possible. So I'll do one thing. I'll join one of the diagonal AC. So I'll give this angle 1, this is 3, as it is 4, so this is 5 and this is 6. So now you can see that it forms two triangles. One is triangle ABC and another is triangle ADC. So you can see that according to the angle-sum property, sum of all the angles, that is angle 1 plus angle 2 plus angle 3 is 180. And the same way, angle 4 plus angle 5 plus angle 6 is equals to 180. So you can see that angle 1 plus angle 5 form a single angle of this quadrilateral. Quadrilateral no एक જ angles है. The same 3 plus 6 is a single angle. So when I do the sum of all this angle, that means angle 1 plus angle 2 plus angle 3 plus angle 4 plus 5 plus 6. So it forms 180 plus 180. As we discussed that angle 1 and angle 5 is angle A. Angle 2 is angle B. Angle 3 plus angle 6 is angle C. And angle 4 is angle D. So thus we obtain that sum of all angles of a quadrilateral is 360.